This is a video to describe how the single mirror object tracker is put together. I'm just going to walk through the CAD design and show how all the components work together. Firstly, many of these components are downloaded 3D files from the internet that are supplied either in an open community or by the supplier themselves. This is the O-Drive board here that controls the motors. This is the Jetson Nano here. This fan was also a downloaded file. The enclosures for the motors here are also downloaded, and these two enclosures were actually 3D printed in the end. The power supply is seen here. This is a buck converter to reduce the 24 volts of the power supply down to 12 volts for the DC fan. Inside, underneath the enclosure, there's also the camera module, which is inside here, and I'll explain that a bit more fully. Most of the other components, however, are 3D printed. The enclosure parts themselves that hold everything together are 3D printed. All this on top of here. You can see there's spaces here shown for fasteners where the bolt will go through here and the nut will be embedded in this slot so that the threads are turning into a nut and not just into 3D printed plastic, because it's more rigid that way. And finally up here you can see the mirror and the bearings here, as well as there's other bearings inside here. I'm going to explode this now so that we can see inside better. Okay, here are all the components that are exploded apart so that we can see what's going on better. So in here is the camera module. It's mounted on a two-part system here, so that with 3 bolts or points of contact, so that we can actually do fine-tune adjusting on the angle. Each of these are in a slot as well, so we can actually do fine-tune adjustment on the exact position of the camera if needed, because the tolerances between the lens of the camera and the inside of the rotating assembly is very, very tight. I wanted to make sure that I could do any fine-tuning that I needed to so there was no collisions. You can see here as well the bearings and spacers to keep everything apart. There's also the gear assemblies here. These are beveled involute gears so that they mesh properly with no backlash. And up here is the yoke that holds the mirror assembly together. It's done in 2 parts here so that this single piece mirror backer can be put in place along with the bearings, even though everything is a fairly tight fit. I'm going to recollapse this and show a split view so we can see what's going on better when it's all assembled. So in this view, just split down the center of the axis for the mirror assembly and the camera. You can see here the mirror assembly, the camera assembly, which is these 2 boards, and they plug into the Jetson Nano over here. But the important parts of the camera are here, and the mirror system, so there's no interference here between the camera body and the rotating assemblies here. This portion here is stationary as part of the enclosure, and this center part rotates inside it, while this outer gear rotates on the outside of the center assembly. And the yoke is actually threaded onto the top of the rotating assembly with 3D printed threads, which ended up working well. I only had, I think, 1 failed attempt to print those properly, but otherwise they meshed together nice and snug. And then you can see here how the system would work. The camera points up towards the mirror, which points out towards the object, but everything in here is free to rotate without obstructing anything with the camera, and it can rotate continuously around the center axis. I can show quickly how the gears, the sprockets, sorry, mesh with their respective gears in here, and the belts, and same for the assembly up above. These aren't perfectly aligned in the design, but they do mesh. I'll just show quickly here how the mirror assembly can turn. So we have this gear here, the sprocket, which is driven by the motor underneath. You can see how it will rotate the outer assembly and the up and down axis, whereas this gear here rotates everything. And you can see how when the X or rotation motor is turned, the tilt motor must also turn to keep the mirror in a stationary position. And so the tilt gear must actually act relative to the rotation gear in order to control the up and down axis of the camera. From this design, I was able to successfully 3D print the components that I needed, as well as make sure all of my tolerances and interferences were good. And this is the main model that I used to print and assemble the final design. I'm not sure the hours included in this, but everything was done here in SolidWorks 2020, the student version, which is very handy to have at an affordable price for the amount of power that it affords for something like this.